Hi, I'm Mike Kucera, an agronomist at the National Soil Survey Center here in Lincoln, Nebraska. Special thanks goes to Sky Wells, who helped me put together this presentation. I'm going to cover ecological sites, state and transition models within those ecological sites for use in conservation planning, and relaying the impacts on soil health, dynamic soil properties, erosion, and water quality. Here is a physiographic image of various ecological sites that you can get an idea of how this can fit on the landscape, and you would expect the different ecological sites to respond differently. Ecological sites allow us to aggregate soil map unit components that are similar across political boundaries. We would expect to find similar climate, similar soils, and physiography, similar native vegetation for whether it's a forest or prairie system, for example. Also similar productivity would be expected. Also similar limitations within these sites for cropping, types of crops, land use, equipment, and conservation practices that might be applicable. Here just shows two separate sites, one more of an erodible site that has those types of limitations, and one on the right that's more prone to wetness, especially in the spring. And so the interpretations and the limitations with these and the management that might work would be adjusted depending on the site. Ecological sites and state and transition models support the 9 steps of planning, which are broken into the 3 basic phases where we gather information, resource inventories, the client's objectives, looking at the practices and systems, and then also once those practices and systems are installed, using monitoring and feedback. Also, they mentioned earlier, they provide suitability or limitations for practices and land use. The potential to improve dynamic soil property and soil health. How far can you move the needle? Response to management and disturbance. What's expected when we apply different suites of conservation practices? What kind of ecosystem services would you expect? Water quality impacts. They're spatially relevant, similar to management zones that are set up for nutrient management planning, as an example. State and transition models provide common on-site indicators for each state that you may be able to find within each land use. Common conditions that you would expect to find if I was a planner that are associated with different management systems. Reference site or ecological potential for each one of those states. How far can we push the needle on improving soil function? Impacts on those resource concerns, both on and off site, for example, soil and water resource concerns. Transitions, how do we move from one condition or state to another? What kind of practices, what kind of management, and what kind of timeline might we expect for that climate setting that ecological site occurs in? Also, just overall decision support for conservation planning on all applicable land uses. State and transition models for planning on all land uses provide us that blueprint with that experience from local planners. Allows us to start real simple, and then as knowledge is gained, add more information and make them more complex or address, look at other issues. Supporting local priorities and programs such as invasive species, restoration of declining habitats, soil health, water quality, whatever that local priority is. Local expertise and knowledge can be gained from common pathways in states. Describe how that management and conservation practices put together in a system would occur over space and time. Separate state and transition models are necessary for each land use. For example, cropland would have separate state transition models from pasture, from rangeland. Also very useful to restore land uses or restore declining habitats or wetlands would be another use. Soil health indicators for common states is also another piece of each state within a state transition model. Those could be physical, chemical, and biological dynamic properties, and how much can we push the needle again. Here's an example of typical land uses on a loamy upland ecological site in MLRA 75, which is in northern Kansas and southern Nebraska. Here you see rangeland and then forests, potentially moving to forests with invasive cedar trees, converting to pasture or cropland. And then you see the transitions with some basic descriptions on how you move from one site to another, or from one land use to another. Within each of these land uses, or you would have a state and transition model that provides information on the type of management. And then, of course, you could tie to each of these the expected conditions and ecosystem services. Here you see a high managed soil health management system where we've improved our dynamic properties and addressed all resource concerns. Down at the bottom is kind of more of a conventional management that's prone to those spring runoff events and erosion and some of the other potential resource concerns that come with that. Here's just a site that I actually was on that we looked at soil dynamic properties, in this case, soil structure. And you see the platy structure that was created from previous vertical tillage. Here's another example where we looked at aggregate stability. On the left, we've got a heavily tilled site in southern Minnesota where we have very low strength and structure. You can see when planting this corn where the tractor tire depressed the soil, compacted it, versus on the right, you can't even tell where the tractor had went to plant because the soil structure and aggregate stability was so good. And you can see some differences in soil color, also in, I mentioned again, soil structure and aggregate stability. Here's just kind of an example of how we could use this. This is an example of conventional tillage and how they're handling their nutrient and weed management. And what do you see? What are the common indicators? There's some obvious ones you can see from this photo. Obviously, what are some of the limitations on this land use of cropland? What practices and management will work for these severe storms like you see here? How can we improve for drought resilience or water quality impacts? How can moving the needle from one set of management to another improve these conditions? Here's just an example on the other end where we have a full-blown soil health management system with no-till, cover crops, the various other practices with as well as an example where this was rotated into perennial hayland and back to cropland. So the resource concerns were addressed fully here. Give you kind of a little better picture, the ecological potential for a site in reference vegetation, native vegetation may be at the top gray bar. And then we can apply, if it's in cropland, some different management regimes and how close can we move to that full functioning system or the potential for cropland. And we may not be able to get all the way up to a native prairie system in this example, but you see with the continuous no-till and cover crops how we potentially can obtain full soil function for things like soil water management, nutrient cycling, efficiency, etc. Some of those major functions. Part of this effort was to develop dynamic soil property studies to look at different management options or regimes and what impacts that they have on dynamic soil properties. In this case, you see 12 site locations around the country with the blue stars. Part of this effort is to develop reference values for soil health indicators for ecological sites and different management groups or regimes, if you will. And the goal is to have accuracy and repeatability of the proposed methods to assess those indicators, and then also the usefulness of those indicators for individual circumstances. How do we tie that to planning? How do we tie that to different management options or management groups? And then also linking that information into our soil survey databases makes it usable in the future. Here's just an example from the 12 from the different locations. And here you see PLFA, which is looking at our fungi to bacteria and the different plant community, microbial communities that occur. And you can see as you change land uses, as you change within one site, the potentials are different with the max, min, standard deviation, as well as mean and mode type of information for these projects. Zooming in a little closer, here you can see on a given site how you could look at it from different basic management regimes, where we have a cropping system with perennial crops. We have no-till with some of the other practices, and then we have more of a conventional system. And you can see how we begin to move the bar upwards as we move towards more of a soil health management system. Tying this to erosion, WEP, which is a water erosion project, and WEPS is a wind erosion prediction system. They both have common user inputs and 7 sub-process models, crop system results and reports that come from those. And you see the processes include soil climate management, hydrology, subsurface and surface hydrology, plant growth, decomposition, and then of course erosion in both models, one for wind, the other for water. Here's an example of the information that can come out of that. This is from WEP. So again, you can see the basic statistics for more of a conventional corn, soybean tillage system and a continuous no-till corn, soybean system. What would we expect for sediment delivery, for water quality purposes, for soil loss, for runoff, plant transpiration, irrigation if it happens to apply. And again, you can see how during drier years, which would be the minimum that you would typically see over a projected 100-year period, and a maximum, which would be the higher precipitation years, what you would expect for all of these for use in risk-based planning with producers and applying practices. Here's just an example where we took a common management system with that we showed earlier, with the high, medium, and low management, and modeled those in WEP. And here you can see the different soil loss, how it increases, and the variability in soil loss and runoff increases significantly from dry to wet years. Also the soil conditioning index, which gives us an indication of soil organic matter trend. So in summary, I've described soil health and dynamic soil properties and ecosystem services such as water quality impacts, how those can be built within state and transition models. Also, this effort will allow NRCS to link dynamic soil properties within our soil survey products. I appreciate your time. If you have any questions, feel free to contact myself or Skywells. Thanks for your attention.